Okay, welcome everybody. We're so excited to welcome Dr. Peter Saulson back for part 2 of Science and Spirituality. We're going to have him get started in introducing himself and about what we're going to learn more about today. Peter, you should have full access to being able to share your screen, and we're just so excited to see everybody. I know folks are still trickling in, but we're really excited to welcome everybody back.
Thank you, Melissa, and thank you all. It's so great to see so many familiar faces that I'm happy to be here with you all. Before we get started, I wanted to offer my condolences to the family of Libby Rubenstein, and I'm especially glad tonight that Zoom has this recording feature, which I saw Melissa turn on, so that anyone who is doing the mitzvah of being at their shiva can listen to this lecture later. I also, before we got started, wanted to take a moment to remember Mark Watkins, who passed away since our last time together. I miss him a lot. He was a good friend, a great mathematician, a great member of CBSCS, and he had hoped to offer some discussions sections in between my lectures. Obviously, that's not happening. That's just one of a long list of reasons to miss him. Anyway, nice to have a memory of him with you all tonight. So I think now, let me see if I can bring up my talk and start the talk itself. Let's see. Tell me. Okay. Could people give a thumbs up if you see a PowerPoint presentation starting on your screen? Okay. See Jacob's hand and Jones. Thank you very much. So I'm happy to be back here with you all. Happy that you are back here with me for this second lecture. The title I announced was Cosmology and Religion, a Dialogue. I've decided to clarify the title a little bit by changing the subtitle to a dialogue about wholeness, because the concept of wholeness, although it's not talked about a lot, especially in scientific circles, is the essential one that I want to be teaching about tonight. And as you'll see, as it develops, that is going to be the theme not only for tonight's lecture, but for the third and final lecture in the series that will take place in person at CBSCS in early June 8th at a Shabbat Lunch and Learn. But for tonight, I'll just be introducing that concept first in the context of the study of the universe, cosmology, and then a tiny bit in the context of religion. So I want to frame the dialogue that I see having developed between cosmology and religion in terms of a pair of questions that I want to suggest maybe are one question. So the two questions are, is the world one? And the other question is God one? And it's okay if the meaning of these questions isn't yet 100% clear. I hope to at least make the notion of, is the world one, make to clarify that question in my presentation tonight. And in the spirit of framing this as a dialogue, I'm imagining a staged dialogue between perhaps Socrates as a representative of someone who was thinking first and foremost about the world outside at least a Jewish religious context, and his dialogue partner, in this case, Moses, thinking primarily about the religious context. Socrates might have been focusing on, is the world a whole? Whereas Moses might have been pondering the question, what is this thing, the Shema, that I've promulgated to the people Israel? What is it really saying? Now, they aren't the last people you could imagine in dialogue about these questions. Let's see. We could also imagine a dialogue between the great early modern astronomer Copernicus and the medieval Jewish philosopher Maimonides, with Copernicus mainly concentrating on the question, is the world one? And Maimonides mainly concentrating on the question, is God one? I know Maimonides in particular wrote a lot about is God one? That's maybe his main theme question. We also might imagine framing the dialogue between two 20th century thinkers, the physicist Einstein and the Jewish philosopher and theologian Abraham Joshua Heschel. Einstein definitely worried a lot about the unity of the cosmos. Is the world one? Heschel very much, how should Jews interpret the words of the Shema, that God is one? And the reason I'm pairing these two together is that these two questions are each in their own way, from their own cultural frame of reference, raising the question of, can we really understand the fundamental nature of existence? And once you say it that way, you realize you're talking about an ultimate question, whether it's expressed in secular or in religious terms. And what I want everyone who's listening today to be thinking about in the background as I go through my formal presentation is, are these two questions really the same question? And to do that, let me suggest that when we think about the universe, we ask, what do we really mean when we're talking about the universe? When we're thinking in religious terms, we should always be asking the question, what do we mean when we're talking about God? And if we interrogate those fundamental terms, then we're prepared to pose the second order question, are those two questions completely separate? Are they the same question addressed differently or expressed differently? Or is there some other way of thinking about these two ways of looking at the world? So in the rest of my formal presentation, the outline is going to look something like this. We're going to spend a good chunk of our time together tonight walking through our understanding of the universe. When I say the universe, usually I'm going to mean the physical universe. And I'll talk about ancient views, which are very illuminating, even though we don't believe them anymore. And then early modern and modern views leading up to our current understanding. And once we have under our belt this tour of the history of thinking about the physical universe, then I want to turn to this question of, is the universe a whole? In what sense can we see it as a unity and not just a bunch of stuff? And I'll look at this on the same historical through line in terms of ancient views of the universe, early modern and current views. And at the end, I'll turn, with not a lot of time spent on it tonight, to the question of why should we care about the wholeness of the universe. I'm doing that in part to set up lecture 3 of 3, the one that will happen in person as a lunch and learn on June 8th. But I do want to set up the question here as an indication of why we're spending so much time on the question of wholeness. And in particular, I'm going to be talking about modern Jewish thought that I learned mainly from the thought of Abraham Joshua Heschel, who we talked about last time. But as Rabbi Steinitz reminded us, it's not very different from the supposed very different modern Jewish thinker, Mordecai Kaplan. And I'm writing Kaplan's term, transnaturalism, as a shorthand for this question of linking religious thought to thought about the universe. So that's where we're going to go. And now I'd like to enter into the topic by pointing out something that when I realized it, it really took me aback. What I realized some months ago is that I'd spent my physics career learning about the universe, and yet I don't think I ever encountered any sensible definition of what the term universe meant. You can look it up in a dictionary and you'll find something like the universe is everything that exists as a definition of the term. But once you start thinking about it, you realize that that definition raises more questions than it answers. And so I'm going to lead us through a discussion that has in the background the question of what we mean when we say the word universe, but we'll approach it through a historical tour of what concepts about existence the word universe pointed to. And you'll see it's a rather dramatic change over history, but one that's very illuminating at each of its stages. So let's start with the ancient understanding of the universe. And on the right-hand side of the slide, I've got a diagram that wasn't drawn until 1524, but 1524 is maybe about the latest year someone could have drawn a diagram of the universe and meant this ancient view. And if you pause and we'll take a bit of a tour of it, here in the center, I hope you can see my cursor moving around, is the Earth. That's located at the center. And then there's the sky. Then there's this strange fiery layer that I won't have a lot to say about, but it marks the transition between the terrestrial realm where life goes on the way we see it go on around us and the celestial realm at and above the sphere of the moon. And we see the moon, then Mercury and Venus, the two closest planets we now know to the sun, Mars, Jupiter, and Saturn, and then out here, the sphere of the so-called fixed stars, and finally an outside that is marked as where God lives. So let's think about this ancient understanding because it will help us understand how we came to have a concept of the universe in the first place. Earth is at the center, everything else, moon, sun, planets, and stars all turn around the Earth, turning, roughly speaking, once per day, but each sphere with its slightly distinct motion making up the richness of how things move around in the sky. And one reason for dwelling on this is it actually explains the etymology of the word universe that we use to point to everything that exists. It actually comes from the notion of one overall system turning around the Earth. Uni for one and verse for turning. So we only even have this word that we find so useful that we can't even usually define it nowadays, from a concept that we no longer believe to be true at all. That's a historical irony that's worth dwelling on a bit. From the religious point of view, religious thinking in the ancient world was pretty well tied to this astronomical view of how the universe is arranged, because the outside of everything that we see is this region where God dwells. And there's a reason God was located out there. This is not so much out of the Jewish tradition, although it was not, at least not the ancient Jewish tradition. This was Greek thinkers who thought this out. God needed to be there because there was a mystery. How was it that this whole vast system of the universe, in fact, did its turning, did its steady turning, never slowing down, never changing, never decaying? And that led to the idea of God as the so-called unmoved mover who was responsible for the fact that the world went in this pattern. Now, let's think about what are the key features of this picture of the universe. On the right-hand side of the slide, I've got one of my favorite pictures of the ancient view, but please don't think for a moment that this is an ancient picture. It came from a late 19th century illustrated book about the nature of the universe. But still, it's incredibly cool. It represents that the ancient concept of the universe, basically you could divide into two regions, an inside where we live and an outside that accounts for how the part that we live in, how it works, why it's there, and what happens in it. And of course, no one really imagined that someone could poke their head through the sphere of the fixed stars and look at the machinery that God used to do this unmoved moving. But it's an amusing thought to contemplate anyway. But the thing I do want to point out is why it was the case that in this ancient view, which after all was held for 50 or 100 times longer than any modern view that I'm going to be defending later, why it had to be finite. Why we couldn't talk about the universe, but thought of it as something that you could draw on a page and not be distorting anything by drawing on a page. It had to be finite because otherwise it was impossible to conceive of how the stars and everything beneath the stars could turn around the Earth once per day. I mean, ancients believed that the universe was large, so they believed that these spheres were turning at incredible speeds in order to go around their vast circumferences once per day. But even they couldn't picture that that would happen if the region where the stars was infinite. Now, one other point of some religious interest, some not small religious interest, is that if you go back and read your Maimonides, say, read his volume on the foundations of the Torah, you'll find that Maimonides thought he could prove God's existence to his readers by saying, well, look, the sphere of the stars turns. There has to be a reason for that. And contemplating that is enough for you to realize that God must exist as the mover of the sphere. And of course, he didn't just mean God was responsible for astronomy, but that God's action in doing that, in fact, led to everything that exists. So when we think about the ancient universe, for everything that's wrong with it, and we know it's fundamentally wrong in all of its details, we can at least appreciate its explanatory beauty, why it served so well for so long, why people were attached to it. And the key wonderful feature is that the structure of the universe, as it was understood by the ancients, showed how it worked and what it meant. It had a center where we live. It had all those intermediate parts containing all the sources of light, all the markers of time, and then it had an outside which was responsible for the existence and the functioning of the whole. So it had this incredible beauty, and it's too bad it's not true. I'm winking at you. Of course, I'm happier to know the actual truth, but you can really see the appeal of this system. And this was universally held until the middle of the 16th century. And it was, of course, Copernicus who, with the publication of his book about his heliocentric view of the cosmos, who overturned this ancient view. And on the right-hand side of the slide is a page from the manuscript of Copernicus's book, and it shows, not with such beautiful art as the one we saw before, Sol, or the sun in the middle, Mercury, Venus, and now the sphere of the Earth. The Earth is demoted to a planet that orbits the sun. The Earth is not in the system at the center. It's the sun that's at the center. And on out, beyond Earth is Mars, Jupiter, Saturn, and finally the fixed stars on their sphere. Now, the thing that caught everyone's attention for all sorts of good reasons was that the Earth was no longer at the center, it orbits the sun. And that's darn important. But what I want to argue tonight is that what was at least as important for how things played out in our future understanding of the universe is that the sphere of the stars, here drawn still as a sphere, is fixed. It no longer needs to be turning once per day around the Earth. Instead, Copernicus had the correct understanding that we believe today, that the apparent motion of the stars around the Earth, and anyone can go outside and see whenever it's clear, that motion of the stars around the Earth is accounted for by the rotation of the Earth on its axis, not by the motion of the sphere. Oops, that went a little bit too fast. Okay, there we are. Okay, so after Copernicus propounded this view, thinking about the universe developed pretty rapidly. The diagram I'm showing you here is another version of the Copernican system, this one drawn by Thomas Digges a few decades after Copernicus's book, but it has one dramatically different feature from Copernicus's own sketch, because notice that instead of there being a thin sphere of the fixed stars defining the outside of the universe, instead, Digges understood that if the stars didn't have to move around the Earth once per day, there was no reason to think of them just living on a thin sphere centered on the center of the universe. Instead, they could be spread out through infinite space. And that was a revolutionary insight that Digges doesn't get nearly enough credit for, but it opened up the real implications of Copernicus's new understanding of the structure of the universe. Now, not many years after Digges put forward that idea, Giordano Bruno said something very similar, but he emphasized yet another idea, that the stars were other suns, and he reasoned if the stars were other suns, there was no reason that those other suns couldn't have other planetary systems. And so all of a sudden, this spatially infinite universe was conceivably filled with an infinite set of habitations for, who knows if they would have been anything like human beings or whatever, but the implications that there could have been life and possibly even intelligent life in many other places throughout the universe was so shocking that when Bruno wouldn't recant it, he ended up burned at the stake for propounding such a radical idea contrary to the truths of religion. Today, we don't burn people with the wrong ideas at the stake, thank goodness. And Bruno is today a hero. But think about Bruno's fate if you ever wonder why Galileo was a little afraid of the church when the church came down on him for his ideas. Just saying. So let's pause and step away from diagrams like this for a moment and just ponder what it was. What was the phenomenon that everyone was concerned with? The beautiful thing that you see when you get a clear night in a dark place. Sarah and I remember views like this in the Adirondacks very fondly, hoping to get some more this summer. So it was people like Digges and Bruno who taught us to see this panoply of beautiful stars as other suns, potentially with other planets, stretching out through a vast amount of space. And it's only been in the past decade or two that we've actually gotten the proof that around many of those stars there are in fact other planets. So this is a story that is still developing and will be developing throughout the lifetime of even the younger people on this Zoom call tonight. there's one other thing I want you to look at in this picture before I move on with the history of ideas about the universe. And that is, in addition to this wonderful nighttime scene with all these individual stars, there's this feature sloping across the sky, this faint band of, dare I call it, milky light. This is, of course, the phenomenon called the Milky Way, which, if it's clear enough, you can see from most spots in Syracuse, and you go outside to a beautiful spot like the Adirondacks, and it jumps out at you in the sky. And not only is it beautiful, but it's mysterious enough that it was worthy of a lot of serious attention after the basic nature of the solar system and the stars was already laid out. And the first key step that I want to call out in the understanding of the Milky Way is attributed to a British astronomer named Thomas Wright, who in 1750 put forward the idea that the sun is, of course, just one among many stars. That was established now. But he said the stars aren't uniformly spread throughout infinite space. Instead, they're uniformly spread through just a thin layer or stratum of space. And the diagram on the left of the slide is a slice through this stratum. So here, this is across the thickness of that layer. And this is the region of space in which there are many stars. And on either side of the layer, to the left side of the left-hand face of the layer, the right side of the right-hand face of the layer, space is essentially empty, according to him. And of course, this is a two-dimensional diagram of a three-dimensional idea. So let me just say, you should imagine that this layer filled with stars extends into the screen of your computer and out of the screen of your computer, so that it makes a flat, thin-ish, compared to its vast extent, region of space in which stars are arranged. And the reason he came up with this idea is he was trying to account for a fact that he'd learned from Galileo. Galileo, one of his 8 or 10 amazing discoveries that he made when he first pointed a telescope at the sky around 1610, he said, you know that milky light that we call the Milky Way? Well, yeah, it looks milky and smooth to your unaided eye, but if you point a telescope in that direction, what you see are a huge number of very faint stars, so faint that you don't see them as individual stars to your unaided eye, but when you aid your eyesight with a telescope, you can see that the light is the summation of the light from stars that are individually too faint to discern. But then the question immediately was, why didn't you see that milky light all over the sky? And Wright came up with the answer that if you lived in a layer, then some directions, the directions that you would look along the length or width of the layer, are directions in which you would see not only nearby stars to you, which you could see as individual bright stars, but there would be a huge number of stars so distant that you couldn't see them as individual stars, but their combined glow would appear as this milky, smooth light, appearing only as a strip around the sky. And these lines drawn in this diagram are supposed to be lines of sight in directions along the Milky Way, where you see all that faint light, and then directions pointing to parts of the sky that aren't in the Milky Way, where there are plenty of nearby stars, but not any distant enough stars to make the milky light. So this is the picture again, and the feature that Wright was explaining is that this milky light only forms a big band that wraps around the sky. And today we know that Wright was correct, and we further know something I don't think he could have fathomed, that this set of stars that we now call the Milky Way galaxy contains about 100 billion stars. And Wright wasn't done. He had another thought, and this maybe I admire even more. What I just led us through is, once you see it, um, uh, just a very nice, clear geometric explanation of how you could get Milky Light in a strip around the sky. But then Wright did something crazy, about as crazy as Bruno. He said, well, I've now explained the Milky Way, but now I've got a picture of the universe that just has this narrow layer filled with stars, and the rest is empty space. What sense does that make? Said, well, it would seem less nonsensical to me, Thomas Wright, if that empty space had in fact other galaxies in it. So he was taking the Giordano Bruno move, except taking it to the next level and saying, what you thought was empty space has more copies of what's nearby, except now the copies aren't new stars besides the sun, but new galaxies besides the Milky Way. And he was, in this insight as well, fundamentally right, although he didn't have anywhere near such good evidence as he did for his explanation of the Milky Way itself. That came a few decades later from the work of William Herschel, who published his most interesting work on this question in 1785, not so long after Wright. And the reason he was able to extend Wright's insight is that he had built a tremendously powerful telescope, and he's obsessed with looking through it. And he spent every clear night outside his house in England. Maybe there were not many more clear nights there than there are in Syracuse, but enough for him to revolutionize our understanding of the universe. And the first thing he did was he paid really careful attention to how many faint stars he saw in the various different directions along the Milky Way. And he said, well, you know, it's not perfectly uniform in all parts of the Milky Way. So it must be the case that this layer that Wright had proposed, even though it's clearly much longer in its long dimensions than its thickness, it must really have a detailed, funny shape in order to explain what you actually see. And in particular, Herschel was worried about the fact, or was interested in the fact, that there are, through parts of this band of Milky Light, there are parts that don't shine very brightly in this faint Milky Light. There are these big gaps that are much easier to see today with photography than they were with the naked eye. But he also saw them with his telescope, and he said, okay, you know, those dark regions, that's because that layer doesn't extend nearly so far away from us in that direction as it does in other directions. So there just aren't so many distant faint stars in those directions. Nowadays, we think the details of this picture don't make a lot of sense, but Herschel was definitely paying attention to the data in a way that I really admire. Now, there's something else that Herschel did that also, in retrospect, is an amazing demonstration of Wright's insight from a few decades before. He could also see, besides counting many faint stars through his telescope, he could see these small cloudy regions about as bright in their individual tiny patches as equivalently tiny sized patches of the Milky Way. He called them nebulae for clouds, but in fact, he guessed and kind of recanted his guess and guessed again that these might be, in fact, Thomas Wright's external galaxies. And he was correct. And in retrospect, this demonstrated that Thomas Wright was correct. And with today's data, we can see how obviously true this is, but of course, it's only obvious in retrospect and obvious with much better observations than any of these great pioneers were able to do. Here is a view of the Milky Way galaxy from the inside, which is, of course, the only place we can observe it from. We have not been able to travel much beyond the moon, let alone step outside the Milky Way galaxy. But if we map where we see light from all parts of the sky and present that all sky map the way you sometimes see maps of the whole globe drawn on one oval shape, you see the basic shape of the Milky Way laid out as this thin layer of stars, as postulated by Wright, with a feature that Wright didn't have, namely that there's an especially dense region near the center, and explaining what Herschel was fixated on, and Herschel called a gap in the layer. We now know that that is just the shadow of dust clouds between the stars. But here is a beautiful view of the Milky Way as seen from the inside. Now, here's a view of another galaxy far, far away from us. One of my favorite ones, NGC 4565. It's a galaxy very much like the Milky Way, and it just happens to be oriented in such a way that it's arranged like the view we have of the Milky Way from the inside. And you can see the layer of stars and the extra dense region near the center and dust clouds. And so Thomas Wright, Herschel were really on to something. So that's just one galaxy. But now if you look in the direction of the constellation Virgo, you happen to see huge numbers of galaxies, several thousand of them. They have a number of different shapes. Here's a spiral. That's another spiral, another spiral. These are so-called elliptical galaxies. But this one picture of a small region of the sky has maybe 1,000 galaxies in it. And if we look even farther, as the Hubble Space Telescope did a decade or so ago, we see the really essential truth of this idea first put forward by Thomas Wright in a move that echoes the thinking of Giordano Bruno, except to the next level. This is a photograph called the Hubble Deep Field, and it's of a completely random direction in the sky. This is a very, very narrow, this is kind of a head of a pin held at arm's length part of the sky at which the Hubble Space Telescope stared for many, many days. I think this is 10 days or even more of Hubble Space Telescope observation time, which if you look at that as a fraction of its time in orbit and how much it cost, this picture was very expensive. But it's fabulous because what it shows, you pick this completely random direction in space, and what do you see? Every single dot in this picture, except for 3, is a galaxy. Some of them are relatively close, the ones where we can see some details. Most of them are so far away that we just see them as tiny little dots. A few of them are not only tiny little dots, they're odd-shaped tiny dots and are very red. Those are the galaxies that we're seeing so far away that we're looking so far back in time that we're seeing them as those galaxies are forming. So this is a fabulous picture that shows us how the universe is filled on the vastest scales, looks back in time, and it says, as far back as 1750, when Thomas Wright said, all that space around us is filled with galaxies, he was right. And you would see the same thing looking in any direction that Hubble Space Telescope might have chosen to point. To prove the point, there's another second picture of a different region of the sky. And of course, every detail is different, but you couldn't tell them apart unless you stacked them on top of each other because the message is the same. Galaxies everywhere you look, both near and far. Now, this is a good moment then to think about how our picture of the universe has changed since the ancient view. This view looks as different as it could possibly look from that ancient cosmos with the Earth at the center, the various planets going around it, then the stars going around it, and God outside. Now we see a universe that has no center, no edge, no outside. Every place is the same as every other place. So unlike the ancient universe, you can't look at a structure that's this uniform, this boring, if I may put a value-laden term to it. Of course, it's not. I mean, I cry when I look at that Hubble Deep Field picture. It's the opposite of boring, but it is so simple and so unstructured that I can call it boring with scare quotes. And you realize that because it has no center, no edge, and no outside, that spatial structure gives us no clue about what the universe is and how it works. But if we examine the universe in time instead of in space, then we see some much more interesting things. So I want to take us through that view as well. Now, I hope no one will mind if I show a short clip from a movie that used to be one of my favorites, Annie Hall. And this is the young character, Alvy Singer, thinking about the universe and what it means. Let's see if it will work.
He's been depressed. All of a sudden, he can't do anything.
Why are you depressed, Alvy?
Tell Dr. Flicker. It's something he read.
Something you read, huh?
The universe is expanding.
The universe is expanding?
Well, the universe is everything. And if it's expanding, someday it will break apart and that will be the end of everything.
What is that your business? He stopped doing his homework.
What's the point?
What has the universe got to do with it? You're here in Brooklyn. Brooklyn is not expanding.
It won't be expanding for billions of years yet, Alvy. And we've got to try and enjoy ourselves while we're here, huh?
So please raise your hands if you could at least hear that sound. Okay, good. So that worked. All right. So here is the young stand-in character for Woody Allen, the author of that film, worrying about what the expansion of the universe meant. And that, of course, is the great discovery that came beyond the discovery that there are many galaxies outside of the Milky Way. That's the story of 20th century astronomy, that if I were giving more of an astronomical lecture than I'm giving tonight, I would have led you through that as well. But let me tell you the basic idea that Alvy Singer was worried about and what lesson it teaches us. So on the right-hand side of this slide, I've got a diagram that's illustrated with things that are looking more or less like a balloon inflated to greater degrees at later and later times. At the top, this is the latest time illustrated, down at the bottom, the earliest time. And you'll see that each of them has the same number of galaxies, but as we go to later and later times, all those galaxies are farther and farther apart. The surfaces of these three balloons are supposed to stand in a way you can sketch for the entire three-dimensional space that constitutes the universe at these three different times. So what the expansion of the universe means is simply that this potentially, and now we believe actually, infinite universe has gotten bigger, is a bigger infinity at later and later times. That's the basic idea behind the expansion of the universe. And I want to make sure that we see the right lesson from these diagrams and aren't fooled by what it's impossible to show clearly in something that attempts to be less oversimplified. First of all, is to represent that is the notion that each of these sketches of a balloon is standing in for the totality of all of the space in the universe at any given time. And it's a three-dimensional space that has no center, no edge, and no outside. Just like those views that we saw through the Hubble Space Telescope. There's no center, no edge, and no outside. So in particular, that means that unlike what you can draw on a diagram like this, there is no background empty space of either three-dimensional character or some higher dimensional character into which space is expanding. Space is just itself, every distance within it getting bigger and bigger as time goes on. And one other idea that I think it's important to understand, although it won't play quite such a big role in the rest of what I've got to say tonight, is that there's no meaning to any time before the Big Bang. So let's ponder both of these things. There's no background space into which space is expanding. There's no outside. We really are in the Giordano Bruno idea, or better, the Thomas Wright idea of more space in every direction. And it's just all getting farther apart from every other part. And perhaps the more profound idea is that space and time actually came into being at the Big Bang. Everything we see and everything we understand about what we see only has meaning in the time since the Big Bang. You can't even form a grammatically correct question about the nature of the universe before the Big Bang. So what we've got is a dramatic story, a story that we can lay out in a timeline, and that timeline is represented graphically by this graphic on the left-hand side of the slide I'm showing now. And in this graphic, time starts at the Big Bang over on the left and reaches the present 13.77 billion years later over on the right. And dramatic things have happened in that 13.77 billion years. The Big Bang, inflation, the creation of all sorts of signals that we gradually have learned to see, the creation of galaxies, and finally their expansion farther and farther apart. And so even though, spatially speaking, we have a featureless universe, it's the same everywhere and extends the same, not only everywhere in every direction near us, but as far as the eye can see. But temporally, what we've got is a drama meaning something that has a beginning, a middle, and an end. And not only that, we've come to understand it because we've come to understand that there are universal laws of nature, laws of gravity, but of all the other forces, all the other ways that pieces of matter interact with each other, and that those laws are universal in the sense that they apply everywhere. So this allows us to then step back again and say, all right, well, what is the universe? Is it simply a collection of all those individual things, all those individual galaxies and the stars in them and the planets around the stars and whatever people or other living things are on those various planets? Or is it somehow more than all of those physical things? And furthermore, is it in some sense a whole? And what I'd like us to do now is try to make sense not of the term universe, but of the term whole. And maybe once we have a sense of what that word whole means, we can think about whether we should say yes or no to the question, is the universe a whole? Now, this is no longer a scientific term so much as it is a term from ordinary human speech, or maybe I should say it's a term from philosophy, from thinking about how we see the world and how it works. And I want to offer one definition of what we mean when we say something is a whole. We say that it's something where we see that all of its parts play a role in enabling the well-functioning existence of that whole. And an idealized human body is one example that we have intuitively as representing wholeness. This is a very famous drawing by Leonardo da Vinci called Vitruvian Man. But here is Michelangelo's David. This is another paradigmatic whole. Sometimes we see things that suggest a whole, even though the whole isn't there. There is a huge number of rather dramatically damaged ancient sculptures, like this one that goes by the name of the Gadi torso that you can see at the Uffizi in Florence. And sometimes some of these incomplete wholes are nevertheless paradigms of beauty, like this statue of Venus at the Louvre. And then in the modern time, of course, we have some irony. And here is the irony of a great sculptor, Rodin, deliberately sculpting a partial whole. I'm not sure I know what this means, why Rodin did it, but it's at least a reminder that sometimes you can see wholeness even when you don't see all of the parts of a whole. So the human body and the relationship of its parts to its proper functioning and its aesthetic beauty are one way of thinking about what we mean when we talk about a whole. But there are other kinds of meanings too. Here's another sculpture by Rodin, the original version of The Thinker. And I brought it to remind us that sometimes when we think about a human being and think about a human being as a whole, we're not so much thinking about her or his physical wholeness, but the human identity or the personhood of that individual is itself a different kind of paradigm of wholeness. And I'll leave it as an open question for tonight that I won't want to get into of should we think of this as strictly speaking related to the wholeness of the body and nothing else, or to something we might call a soul, or to things that don't have concepts that don't have such a load of baggage as the word soul. Let's just leave it as an open question for now. But human identity is an important paradigm of wholeness, at least as important as the integrity of a human body. Now, here's yet a third paradigm of what we mean by wholeness. This is two sketches of a living cell, in this case, an E. coli cell. And in the left-hand picture, you can see a view that includes a cutaway view of a complete E. coli bacillus. And on the right is a really wonderful zoom in to a small portion of that bacterium. And each of these different funny shaped colored regions represents a different protein that's part of the interior of the cell. And the reason I'm bringing this picture for us to contemplate is living cells work because of the interacting functioning of a vast number of parts. And all of those parts, maybe not every exact copy of every protein, but they all play a crucial role in the fact that that cell is alive and can reproduce, and in this case, maybe make us sick, I'm sorry to say, but a mutation of even one of those kinds of protein might cause it to malfunction catastrophically. So it's definitely a whole in the sense of a system that depends on the proper functioning and relationship of all of its parts for that whole to do what it does. And now there's one other kind of paradigmatic whole that I want to bring to our attention, and that is thinking about society as a whole. And the image that's on this slide is the frontispiece of the famous book by Hobbes, came out in 1651, called Leviathan. And you can see the image here of Leviathan. In a moment, I'll make it clearer by showing you a zoomed view, but let's just take, before we stare at it, the basic idea that Hobbes had is that society can be thought of as a whole in the sense that it's made out of parts, the human beings who are part of the society, and it has a form, the social arrangements between the people who make up the society, and it gives the whole, the society as a whole, powers that extend far beyond what any individual person or small group of persons could achieve. And here's that zoomed in view, and look at this amazing thing that it's hard to see if you don't look close up, that this Leviathan representing society is literally made up of, in this sketch, a huge number of individual human beings. I think it's an amazing piece of art. And it represents this idea that in the social sense, as well as in these other senses of other kinds of wholes, that the whole is more than the sum of its parts. So now I want to finally turn to a question that I've been posing off and on since the beginning of our time together tonight, and that is the universe a whole? The ancient universe was a whole. It had a center, an edge, an outside, and you could understand the relationship between those parts as representing the function of that whole universe. But now let's pose the same question for our modern understanding of the universe. And if we just look at it from the spatial point of view, the universe doesn't appear to be a whole. It extends to infinity. Every part is just like every other part. There's no way of understanding function from structure. So we can't see the role that each part plays in the whole, can't see what it did, what it's for. So maybe the universe isn't a whole. But we can also think temporally and not spatially. And when we view the universe as a story in time, then I claim that the universe really is a whole. It has a beginning, the Big Bang. It has a middle, times like the present. It has an end, this accelerating expansion that we've recently discovered that will drive the universe in future eons to utter emptiness. And it has a wholeness in the sense that Aristotle said a well-formed drama is a whole, a beginning, a middle, and an end that makes sense. And some people have asked, well, does that mean we are literally back to the story of Genesis with a creation moment? And I want to say, no, I'm not making a claim that that is that transparently and literally religious. I mean, let's look. Does this diagram, this timeline of the Big Bang, look like these images by William Blake? No, I don't think so. The timescales are different. The steps are different. The spatial arrangement of parts is different. It's a theory that comes from physics. It doesn't describe a reason for any step happening. It doesn't say things are good. So the Big Bang story, as we learn it from physics, is not just a recapitulation of the story of Genesis, as tempting as it has been for some people. But it's nevertheless got a different kind of religious significance, because I want to claim that a common origin, a common development, and a common destiny for everything is a genuine form of wholeness. And in a certain way, maybe it's even more whole than the ancient view. There's yet a third form of wholeness that I want to claim our universe has that the other one didn't. And that is something that I mentioned in passing earlier, that we have universal laws of nature that govern how every part of the universe interacts with every other part. Now, if this set of cryptic squiggles on the right-hand side doesn't mean anything to you, that's okay. It doesn't mean anything to anyone else on the call except possibly for me and one or two other physicists who might have snuck on. That's fine. It's just a reminder of this profound truth that there is a small list of laws of nature that apply to everything, that govern how everything interacts with everything else. And my favorite Jewish thinker, Abraham Joshua Heschel, realized that this was an important indication of wholeness. He said in one of my favorite sentences of his, that the idea of the universe is a metaphysical insight. And he went on to say that things are not entirely divorced from and indifferent to each other, but are subject to universal laws, and they form, by their interactions with one another, a universe. That is to say, a whole that could be understood. So the main point I want to make tonight, and in the remaining few minutes before we reach the 8 o'clock hour, and I want to just point to where this might lead and how I'm going to use this in my third and final class of the series on June 8th, that when we consider the universe, we can recognize that it is a whole, both from its common origin and also history and destiny, and also from the fact that throughout it is governed by laws that indicate how things relate one part to another. And this is true even though the spatial markers of wholeness that were the source for the ancient belief that the universe is a whole just aren't there. But nevertheless, the universe is a story in the sense of Aristotle's well-formed drama from the Big Bang through now into the future that makes some kind of sense through the law-governed activity of all the physical parts of the universe. So I want to claim that I've made an argument that I find persuasive, that the world is one. It has a kind of unity, a wholeness to it that helps us understand it in a big picture sense. But that ought to, for any of us here, raise the question, what might that or might that not have to do with the question, is God one? Is there any reason to think that religious thought can be influenced either for good or ill from this scientific knowledge and this contemplation of the meaning of scientific knowledge that we went through when recognizing that the physical universe is a whole? So another way of phrasing this question is, does the oneness or wholeness of the universe tell us or give us good reason to suspect anything about why we should know if God exists, or granting that God exists, that God cares about us and cares about what we do? It's a whole separate question. Now, modern Jewish thinkers have indeed offered us a reason to think so. My favorite, Abraham Joshua Heschel, illustrated on the right, and the other great 20th century thinker, Mordecai Kaplan, whom we were reminded of in the question period by Rabbi Steinitz last week, both argued that there's more to existence than just material things. And Kaplan had this great term, he called it transnaturalism, same idea that I called expanded naturalism in the first lecture. And if I can describe the idea that transnaturalism points to in just a few bullet points, it might be that values are real, not just physical things are real, but values too, that persons can make genuine choices, and that there are moral laws alongside laws of nature. And whether I persuaded all of you all last time, this is something, an idea that I'm willing to defend again, and that was the point of the first lecture, for me to defend that point of view. And it's out there in the furniture of our looking at the world for us to ponder, and we will do that next time. So let me just point in 2 more slides with where this might go and where I hope to take it when I see you all in person on June 8th. So let's come back to the crudest meaning of the term universe. The universe is everything that exists. Let's frame that from an explicitly religious point of view. The universe is everything that exists, but I, along with Heschel and Kaplan, hold that the difference between good and bad is real, and therefore that values are real, that values exist. And if they are real, then there's more to existence than just the physical. And therefore, everything that exists can't be solely physical. The everything has to include features like values and persons. And so Heschel made what I will present next time as a profound argument for belief in God, and that's what I'll be working through when we're together in early June. And the key will be to follow Heschel in thinking of both the material world on the one hand and the world of persons and values at the same time when asking questions about, is existence a whole? And this will be the topic when we get together, when I present in detail Heschel's argument that God is the whole of everything that exists, the everything being the material and the realm of persons and values. So I'll be happy to take your questions. I see that there's already one hand up, and let me stop sharing and look at you all in a better way. Good to see you. In fact, I see several hands up. Melissa, are you here to moderate, or should I be self-moderating here? Not hearing or speaking, I'm going to call on the first hand up that I see, which is labeled Hanita, but it might be Howard. So whichever Blair is raising a hand, please unmute yourself and ask.
Okay, had to unmute there.
Yeah.
It's Howard, and
Hey, Howard.
hi, Peter. I just wanted to I have a couple of remarks that I'll make. I'll try to be as very succinct as I can.
Sure.
Plato had a concept. He had this concept called the divided line, and the fourth and highest segment of this divided line is about something he called aporia, which I think I'm pronouncing it correctly, which is a kind of knowledge beyond even a knowledge and wisdom beyond even reason, that one is philosophical wisdom that one aspires to, contemplation through reason and other means. So I'm mentioning that because of it calls into question really pondering what understanding itself amounts to.
Sure.
Right. And by the way, Bertrand Russell had a much more basic kind of thing that sort of bears a relationship to that concept of Plato's, which is he divided knowledge into two broad categories of knowledge by description and knowledge by acquaintance. Okay. And so typically, most of, I think, what is done in science, in working, scientific work, is the accumulation in the record, so to speak, of vast, ever-increasing knowledge by description. And that is dealing always with structure, or structure and dynamics and so on, dealing with the mechanical. In fact, I think you once said that in a talk you were giving in the library at CBSCS. And but knowledge by acquaintance is knowledge of what things are like. I mean, one kind of knowledge by acquaintance, at any rate, is what's it like. So we can have a description. We can know a description, but we can also know what it's like to experience having that description, and they're two different things.
Yes.
So that, anyway, there's that. But regarding wholeness, it seems to me that just from physics alone, we have a notion that the state of each and everything is dependent to some extent on the states of everything. Yeah. So that the universe then becomes a kind of whole of the interrelationships between the states of everything.
That's beautiful.
Okay, and this is reflected in a Hindu concept, Indra's net. So the concept of Indra's net is you have this vast net, and each like a fishing net, and each node in this net is a jewel that perfectly reflects the entire net. Each jewel's identity really is acquired from its position in the network, but the position is just given by the reflections it has of everything in the network itself. So that's a rather beautiful image of those interrelationships. So that, for the time being, is it.
All right. Well, thank you for all of those reflections, and it gives me a chance not only to say thank you for adding all of that to my presentation, but for pointing out in a very gracious way that there are many ways to approach a profound understanding of the world. And I tend to follow the person I've learned the most from in my life, Abraham Joshua Heschel. But the more I learn about other thinkers, I can see people he was quoting from, people he was responding to, or other sets of metaphors for ideas that Heschel expressed in the Jewish set of ideas that were his stock and trade. So it's really nice to be reminded that of the range of other thinkers who are grappling with similar kinds of issues. So thanks very much for that, Howard. Okay, I see Jacob's hand up. You want to unmute Jacob and ask away? Can't hear you. You haven't yet unmuted. Sorry.
Yeah. So I know I took up a lot of time last time, so I'm going to limit myself to one question. So, how do we meaningfully determine which structures are wholes? Because you brought up a few counterexamples with the the statues that were constructed to look as though they were unfinished, but are in and of themselves whole in some sense. So how do we determine which things count as wholes and which are just parts or non-wholes? And then adjacent to that, how is that related to whether or not goodness or badness are a more real part of the universe than just things that people have stipulated?
All right. So those are two questions, but they're two good ones. I will take them both.
All right.
So in terms of recognizing wholes, I think the principle is, can you see that each of the parts of that whole play an essential role in the functioning of the whole? And there's, in our human life, we know why it is great to have two arms, two legs, a head, so on and so on. Not to say that human life is impossible if you lose an arm or any of a number of other disabilities, but we understand someone who is lacking one of those ordinary features of human life by reference to how we understand why it is that that it's great to have a human body like, we should all be so lucky, like Michelangelo's David, okay, the Vitruvian Man. In showing those broken holes, I wanted to suggest precisely the question that you raised, that it's a bit ill-posed, but holes when you see them. A well-formed human body when you see it. You understand the functioning of a cell when you understand it and how it's related to the various parts. You see how societies function through the interaction of all their institutions and their individual members, even though we don't perhaps have the notion of the divine right of kings that Hobbes was trying to defend in his book, The Leviathan. So the paradigmatic examples are clear. The borderline cases we understand by reference to the paradigmatic examples. And for the purposes of tonight, I only want to leave it with those examples. I don't want to make use of the examples in the religious context, but I will do that on June 8th. But now to your other question, just to be clear, tonight at least, I'm not saying that my claim that the reality of values or the true existence of free will in persons is clearly making up part of the whole when we study the nature of the universe. For the purposes of someone just being a physicist or an astronomer, recognizing the features of the physical universe that I called out, that's enough to recognize that system as a kind of whole. Same with a biologist understanding a cell. The biologist says she understands the cell when she can say, okay, now I know why that protein is coded for by that part of the cell's genome, because it's necessary to do this thing that lets the cell move or digest or whatever it is, the many, many functions. You can ask the question again on June 8th. I hope to see you there in person. And then it will be, on the table. For tonight, it's just a separate parallel assertion of mine as a setup for a time when we can talk that through. So thanks for that. Okay, I see Rachel Friedman's hand up. Please unmute and go ahead.
Okay. So I was really taken by the pictures that you had of the cell and the cell like really close up. And
Yes.
So the picture of the cell really close up, and it made me think about, so this is my question. So how does science know that we're not just looking at that close-up view of the universe, like that close-up view of the cell, and that there isn't some sort of outside of that?
Thing. Great question. And I can tell Jacob, among other people, also approves of the question. So yes, and perhaps many of the people here together in the Zoom room have heard of ideas that go by various names like the multiverse or something else like that. There are ideas out there in the world of science and science adjacent thinking. And I'm not sure whether the multiverse idea is science or science adjacent. It's a very extreme speculation, but it's not groundless. And if I put aside the digs I want to throw at people who say, oh, the multiverse we know is true, okay, your question is still a well-posed one, or at least it's not well-posed, but it's a sensible question. It's not well-posed because of, I think, the answer that you already suspect inside of posing your question. You say, what if it were true? How would we know? How could we look and see and get evidence? And that's really the hard aspect of it, because unlike the situation of the cell, where my body is made of cells, but there's other cells that I can put on a microscope slide, and then I can look at them from the outside. I can either literally or figuratively cut them open. I can change the focus on my microscope and look through. We can't look if there are other universes. We can't see them. The light that we use to get information about the universe travels in our universe. It travels in the space. It doesn't get from one to the other. And no one who's a proponent of the multiverse that I've heard has actually proposed any idea where we could get any information about any empirical information, that is to say, about the existence of parallel universes. Maybe that situation will change. If it does, the idea then becomes fully a part of science, and then we can try to investigate it with the kinds of tools that work for science, proposing a possible understanding of what we might see, comparing it with what we do observe, seeing do they agree or not. For now, it's mostly in the realm of speculation. But your question not only was a good one just in its own right, but it raises another more profound idea behind the words that you said, and that is, if we're really interested in wholeness, we want the largest possible picture. We want the most complete understanding and description of the universe. And if it's possible to postulate things we can't even observe, then shouldn't that make us feel an important form of humility about our knowledge? And if that was behind your question, which I suspect it might have been, then good for you, that is correct. We always need a kind of humility about what we claim to be our knowledge. And I think that was one of the points in Howard Blair's remarks, that beyond the things that we can claim to really know, there are things that may very well be true that can be hard to know by the methods that we normally take to obtain knowledge. Now, I was going to get to a version of your question that I think I saw Jacob type into the chat, and that is, if there is a multiverse, a many set of universes, just like there were many stars as proposed by Bruno, and many suns, and many galaxies as proposed by Thomas Wright, could there be a kind of wholeness that encompassed all of that? And I'm of the belief that if it turned out to be true, we could eventually come to understand it in terms of a higher principle of relationships among those different universes, and that we could at least aspire to that kind of understanding. That would be our goal. If we didn't aspire to that, we would stop being scientists about it. But if we could first establish that the idea made sense and then find ways to investigate it, our investigation would consist of trying to find the unifying principles that would let us understand why there is this universe and that universe and the third one. So we could still aspire to recognize a new kind of wholeness, but of course it wouldn't look like the evidence for wholeness that I presented earlier in that talk. So thanks very much for such a deep question. And I hope I didn't start out by insulting it too much, because it's a great question. Thank you. So are there other hands? Okay, Sam, yes, I see your hand. Please unmute.
Okay, this is just a astronomy question.
Sure.
when you talked about the universe as ever expanding, and you said there's no edges and no center, I get the no edges part, but how can there be no center if it's always expanding? Doesn't it have to be expanding from somewhere?
Yeah. That is the common sense view. And so I'm really glad you brought it up, but it's not the view that we hold. And let me try to motivate it. And it's a good reminder that I actually rushed through those balloon images too quickly. The sense you're supposed to make of those balloon images is to imagine that you are a two-dimensional creature, say an ant that doesn't have a neck that can twist, an ant that can only look forward or sideways or back, but not up and down, and an ant that can only crawl on, not a flying ant, but an ant that can only crawl on the surface that it's on. So that kind of creature, that kind of mythical ant, if it were in a universe that was like the surface of a balloon, would be an analog to what I'm claiming to be true for us three-dimensional creatures living in a three-dimensional universe. So think about the ant, this mythical ant, crawling on that more or less spherical surface of a balloon. It can move forward, it can move back, it can turn left, turn right. It can crawl, in principle, all around that universe, but it will just encounter more galaxies wherever it goes. Each decorated region of that balloon looks more or less like any other decorations of any other parts of the balloon. And it could, in principle, if it crawled far enough, come back to where it was, but it would never cross an edge, nor would it spot any place that seemed any different from any other place. So the most obvious thing about that is the thing that you said is clear, namely that there's no edge. But I claim that if existence is confined for that ant to those two dimensions, then there's no center either. The thing that we see in three dimensions as the center of the balloon that keeps getting more and more air doesn't exist, really, for the ant. Now, my claim is a little more radical. I'm saying that we live as three-dimensional creatures in a three-dimensional space that's analogous to the two-dimensional ant on the two-dimensional world, but I'm claiming there's no fourth spatial dimension that those three dimensions are wrapped around, and we say, oh, that's the center. There's only the expansion of space. And there's no part of that balloon that's the center of the expansion, and there's no part of our three-dimensional space that's the center of the expansion. So does that make a puzzling idea a little less puzzling, Sam?
Yes, somewhat. Thank you.
Somewhat. Okay. That's all I can hope for. Thanks. Okay. Are there other questions? Oh, I see Mark Field has his hand up, and then Bob Tornberg. So Mark, go ahead, please.
Okay. At the beginning of your presentation, I think, were suggesting that those really fundamental questions could collapse, or they might collapse into one. But it seems to me that there's a very important divide between those two questions, and the divide, I think, is made apparent when you posit that the material world lacks consciousness and awareness, and the God world contains it. So how does one collapse those two ideas that don't seem to be collapsible?
Okay. What a profound question, and I'm not surprised to hear you raising a profound question. And I will give you a preview of exactly that tension in Heschel's thinking. We'll come back to it in more detail, both that will help you, but other people who maybe weren't even ready to ask that question tonight. I hope everyone will be ready to ask that question partway through my session on June 8th. So when you read Heschel, sometimes he seems to be saying, well, you really got to think of existence as having two separate realms, except he doesn't use the word separate, but two realms. Forget I said the word separate. The realm of the material and the realm of persons, values, cluster of ideas involving persons and values. But we know from our own experience that they must have some intimate connection because we as human beings participate in both. We have material bodies, but we also have consciousness and we have values and we make our choices. We act towards trying to achieve a good outcome, while at the same time being subject, because of our physical bodies, to how the laws of nature say, you know, you want to lift a heavy weight, your muscle has to do this mechanical thing in order to lift it. So, of course, your question is precisely the profound one, but we already have this clue that whether we ever get a good, clear answer to that profound question, that there must be an answer, because we see that these two realms, that when you try to describe them, seem entirely separate, they must be intimately connected by our own experience. Okay, so is there going to be a crisp one-sentence answer that will then resolve all puzzles about that? I won't promise that, but if you start from knowing that if you're going to analyze existence in this way, that analysis has to live alongside the kind of higher unity that we know must exist simply because we exist as human beings with a stake in both realms.
Okay.
So I will try to make it a little bit clearer next time when I first lay it out, and you should ask the question again at the end if it's not clear, which it probably won't. Okay, but that's a preview. Bob.
Yeah, so I felt like I was following you in your great explanation of the expansion. And then you threw in that there's an end to the story. And I'm trying to figure out how the expansion can't be infinite and that there's an end.
Okay, all right. I should have said end with scare quotes. Thank you for that. There's an end. All right. All stories about the ultimate destiny of the universe are subject to change and correction. The one I'm going to describe has come to be what physicists and astronomers believe, but they've only come to believe it in like the past decade or so. Right? And anything that we've just learned, you should be somewhat skeptical that it must be the ultimate truth. Okay? But with that caveat, let me say the current belief. The current belief is that the expansion will continue for infinite time. So in that sense, I shouldn't have used the word end. I meant end in the sense that I can speak a sentence describing that infinite outcome. And here it is, that what we've learned in the past decade or so is that expansion is not just going to continue, it's going to accelerate. And so rather than the universe very gradually becoming emptier and emptier, it's going to rapidly, at least on cosmic timescales, become much, much emptier. And it's an end in the sense that it will become a boring world for existence. Stuff will be so far apart from each other. Yes, and there's Jacob's beautifully snide but insightful comment. It's lived emptily ever after. So thanks for that. So it's not an end in the sense that the universe will end on January 1st, 2,375,000,000 years. Okay, it's an end in the sense that there won't be any more story to write, and that those late days will feel very different from the current time, and surely also very different from the early universe as well. So it's an end, not an end. Does that help? Okay, good. All right. I see a hand that I think is Howard's again.
I'm not trying to be a wise guy in asking this question, but I want to go back to the beginning, which is, was there actually a beginning or just ever earlier moments epsilon greater than 0?
Well, it depends, Howard, if you like to think logarithmically or not. I suspect that you are happily thinking logarithmically, and from a certain logarithmic point of view, we have no capability at the present time, and we don't foresee the capability of really understanding precisely t equals 0.
Okay.
However, if you think in terms of ordinary units, there's a meaning to t equals 0 happening 13.77 billion years ago.
Sure.
So, okay.
Okay.
Good. I see Joan's hand up.
Did somebody else have a hand up?
Did someone else have a hand up?
Okay. So I just want to point out that Melissa has been busy with a Federation program in the synagogue building, which is why she has not been on the whole time. And it is 8:30.
Yeah.
So I think this is our ending point, and I'd like to thank Peter tremendously for another incredible presentation, and hope that everybody will come and join him in person when he comes in June, and we're all waiting for that. Have an opportunity to see you and talk to you live and not just over Zoom. So
Okay.
thank you again, Peter.
Okay.
For
And thank you all for your attention and for your great questions afterward. Look forward to seeing many of you in June. Bye, everyone.
Good night, everyone.